In maths, we've been looking at transformations of periodic functions, and we've been talking about the fact that we can model real life data. And that's what we're going to do today. And I'm actually going to take you through an example of how we do this. So I'm using the Graph app, which we have got on our system at school and that you can also download for free. So the first thing I've done is I have used the ability to plot a series of points. So this graph shows us the daylight, the hours of sunlight, so going from sunrise to sunset over the period of a year. So it goes over 52 weeks. So the first thing that I've done is I've set up my graph that's here, and you can see I've got my x-axis, which is time, and it's time in weeks. So it goes from 0 right through to 52, and we have our points here, and you can see on the y-axis these are the hours of sunlight. Now, after you have actually graphed your points, so you've plotted your points, the first thing I want you to do is put in your first thought bubble. And here is what I've got. So I know that my maximum value out of all my points, my maximum y value is 14.4, and the minimum value, so this one here, is at 9.9. That lets me work out two things. It lets me work out the amplitude of my function, which is 2.25, and it allows me to work out where my line of equilibrium is, which is 12.15, and you can see the calculations that I've done there. So that's the first step that you need to do when you're actually going to model your functions. The second thing that you need to do is you need to decide what function your graph is going to be based on. Now, if we have a look at the shape of the dotted line there, you can see that it's higher at x equals 0. This would indicate to me that it's going to be a cos curve, because we know that on a standard cos curve at x equals 0, our y value is going to be 1, so our curve is going to start that way. This gives us the start point for our modelling. So using our whole equation of a cos bx plus c plus d, so our general equation of a trigonometric function, we can put in 2.25 for our a value, and immediately we can put in 12.15 for our d value, because we know what our line of equilibrium or our vertical shift is, and we know what our amplitude is. So when we do that, this is what we get. And up at the top here, you can see that our equation that we've got there is 2.25 cos of x plus 12.15. Now, the first thing that I'm looking at there is I can see that it matches my maximum and minimum really, really well, but our period is far too short. Now, there are a couple of ways that you can do this, so I'm going to take you through the trial and error way first, and then I'll show you the shortcut at the end. So I know that I have to stretch my graph out, and by stretching it out, I need my b value to be smaller. So let me start straight away by taking it down to, so it's got to be under 1. So let me take it down to around 1/10 of that to start with. So we'll have a look at, well, there's 1.6. So once again up here we can see on our pink line we've got 2.25 cos of 0.16x. Now I'm starting to get a bit of a shape there. It's looking right, so I've got a bit of an idea of what I can do. So there's a few different things I can try from this point in time. So I'll get rid of the green line, and we'll just work on this one to start with. So one thing I could do is make it smaller again. And here I've made it smaller, and I've actually moved it to the right. So you can see that I've made my, by looking at the yellow line up here, my value is now 0.14 because I wanted to spread it out again, and I've moved it to the right, but it's still not sitting that well. So let's try something different. Let's try this time moving it, making it smaller again and keeping it the way it was. So it's now still based at the beginning. So there's no shift whatsoever, but we've got a 0.12 as our B value. So that's actually looking pretty good. So I'll get rid of my pink line and my yellow line. Now, if I could move it back to the left just a fraction, it would have my points here lining up again. So let's try that. Let's try moving it. And of course, to move to the left, it means I have to add something as a C value. And there we go. Now that line is probably the closest fit that I'm going to get. So I can now talk about the fact that my model is 2.25 cos of 0.12 x plus 1 plus 12.15. If you're a bit confused about that, have a look at the top right of the screen and you will see the equation of the line there. Now, when I'm talking about my model, I can then talk about strengths and weaknesses. So a strength of this is it fits quite well and it gets the majority of my points there. I can talk about the fact that there could be errors in the data because we are dealing with real data, and that period of time that is not quite on the line, we could talk about the fact it might have been it's longer daylight hours, so it might be that it was absolutely clear sky that day and there were no clouds causing the darkness to come earlier. It might be that there was human error. It might be that for those couple of measurements it was taken at another weather station rather than the first one, that the rest of them came from. So there are things that we can talk about. Real data, it is very rare that the real data will actually map precisely onto our model. Now, I did say that there was another way that I could have given you an even quicker way of getting to this point. So that's trial and error, and I'd expect you to be showing each step of what you did. So when you submitted this, you would actually be wanting to submit it with all of the other lines on that I'll put there in the end. But the thing that you could also think about is this. Our time went for 52 weeks. So our period is actually, our B value needs to be over a 52-week period. So when we divide 2 pi on B, if we use 52, we'd get 2 pi on 52, which becomes pi on 26, which is 0.12, and lo and behold, that's what we actually needed to have there for our value for B. So we can actually use our real data to give us a guide as well, and that certainly helped that out. Let me just put all of the graphs back on so you can see how it started and how it was tweaked. So we went from the fact that we've got this green line, which has just our period of X, right through to getting to the actual model of our data, which we've got now in our top right-hand corner. This is the sort of thing you need to do for your assignment. So starting off with your actual data, plotting it, and then working through to get your model, and remember to show your thinking every step of the way. This has been a bare basics lesson on how to actually model some data using transformations of periodic functions. And remember, the idea of bare basics lessons is to make maths just that little bit more bearable for you.